Here is a demo result of scene 066500 of Scanet V2 dataset. Our system consists of a real-time 3D reconstruction using Infinitam module and an online 3D semantic segmentation module, Supervoxel CNN, which performs the online 3D semantic segmentation along with the 3D reconstruction. This is the 3D semantic segmentation result.
The local means filtering has been successfully applied to Monte Carlo denoising. However, applying it in the image space limits capabilities. We propose a transform-based network with self-attention mechanism, which performs non-local means filtering in a high-dimensional feature space. Specifically, each position on the feature map will get a non-local information from other positions within a feature patch, guided by the learned self-attention map. We also propose two adaptations to better unleash the potentials of self-attention. Our method can better recover structures and reaches the new state-of-the-art. Come join our talk for more details.
Monte Carlo rendering computes images by chasing massive light paths, but is prone to unpleasant noise at insufficient sample rates. Denoising is a powerful technique to quickly get clean results. Unfortunately, it's too difficult to find the denoiser that works well in all scenarios. We propose ensemble denoising, an algorithm to combine multiple denoisers by solving the optimal weights per pixel. We robustly achieve better results across scenes and sample rates, both visually and quantitatively. Welcome to our talk for details.
Monte Carlo integration of a function relies on averaging its values at randomly chosen positions. One way to improve its convergence speed is by carefully choosing the sample positions. This can also be done in higher dimensions. Since in rendering each bounce is integrated sequentially, uniformity for consecutive 2D projections is also required. Here, you can see that classical Sobol sampling projections are not satisfying. We introduce a new construction applying Sobol permutations in a cascading manner. Our new construction guarantees 0 M2 nets for consecutive projections, while keeping a low discrepancy, which has a positive impact on rendering.
Scenes with a lot of indirect light take a long time to pass trace. State-of-the-art methods need hundreds of samples per pixel for many scenes, even with denoising, makes it hard to get quick previews for complex scenes. We show it is possible to extract more information from the same paths by constructing a graph from all the paths. We iteratively refine the estimates of light in the scene and let it converge to a steady state with less noise. We can get good results even with just one sample per pixel. Come see our talk.
In many light rendering, researchers introduced light hierarchy and light cut to organize and sample large number of lights in a scene. However, it is still very difficult to find a good light clustering and a probability distribution for important sampling. With predefined light clustering built with a fixed weighting function, the Monte Carlo methods may converge very slowly, which will lead to very noisy results, even when we can learn the visibility gradually. To resolve this issue, we present an online algorithm to learn a good light clustering configuration progressively. If you are interested, please come to our talk.
Frame interpolation and extrapolation are common methods for increasing frame rate. However, interpolation methods will inevitably introduce latency. For extrapolation methods though, there are two main challenges: disocclusion and dynamic shading change, which cannot be handled very well by traditional extrapolation method. For solving these problems, we propose an extrapolation pipeline, which takes G-buffers and demodulated frames as input and passes them to ActionNet, a lightweight neural network to do disocclusion feeding and shading correction. Our method can generate smooth sequence without noticeable artifacts. For more details, please come to our talk.
Volumetric path tracing can handle general light transport by tracing path samples through a volume, but it's too noisy for interactive volume rendering. Our new technique generates a few candidate samples per pixel which only need to be approximately evaluated, and reuse them spatially and temporally to gather a lot of candidate samples to form an approximately perfect importance sampling distribution where we can draw a final sample that is accurately evaluated. With that, we achieve low noise, interactive volume rendering that can handle complex seeing and lighting, including multiple scattering, many light rendering, and explosion. Come to our talk to learn more.
Spherical harmonics have been proven as a powerful tool for rendering, but computations of SH products are often the bottlenecks. For k-input SH vectors without an n, the brute force waveform product takes n to the power of 2k time. But our method just has a time complexity of kn cubed plus k squared n squared log kn, which is much cheaper than the previous method. For real applications, our method could reach 10 times speed up. Thanks for your listening. Please come to our talk for more details.
High resolution and high refresh rate displays push GPUs to the limit. When the GPU bandwidth or power budget is limited, we need to choose between low resolution and low refresh rate. We propose a visual model that can best find the compromise between the two. Given a physical specification of a display and the content of the screen, we can find the optimum frame rate and shading rate for each 16 by 16 VRS block. We can maximize the visual quality of real-time rendering without eye tracking and at a minimum computational overhead. Future rendering will be adaptive and will make the best use of high resolution and high refresh rate displays.
Displacement mapping is a powerful tool for adding geometric details over a surface mesh using a texture. But ray tracing displaced surfaces is challenging as micro details must be made random accessible. Tessellation requires discretizing texture mapped displaced surfaces, leading to unacceptable memory usage for high resolution displacement maps. We propose instead a displacement-centric acceleration structure that can be mapped as a texture on triangle meshes. The actual bounding volumes are only computed on the fly at ray query time. Our method enables interactive design choices, such as modifying the displacement amplitude or increasing the amount of tiling, in real time with minimal memory overhead. We also support geomorph level of details and a range of local reconstruction filters.
We present a novel approach to the sky materials and